And so when we start to learn about different elements and compounds and their properties, density of the material is just going to be something that pops up over and over again. So let's spend some time here talking about what that means so that when you see the word density in your book, you're not worried about it, you're not taken aback by it, you totally understand what that means. First of all, density is a word that we use in our everyday language, so most of us, have some idea what density might mean, even without talking about chemistry. So ask yourself that. What do you think the word density means? Usually we talk about something being dense or not being dense, and usually when something is dense, it means it's hard to understand. Somebody's dense, maybe they're hard to get along with, something like that. That's sort of what we mean in our everyday language. But getting more towards the language of science, if you think about what something that's dense might mean, you might think of something being heavy. You might think of something having mass because it's very dense material. You might think of lead being very dense because it's this big heavy thing. You might think of feathers not being so dense because it's just kind of this lightweight stuff. So you know that mass / weight play a part in the definition of density, but that's only part of what we're going to find that we have. So the first thing you need to sort of know, and I know that you all know this, is that everything around you has mass, right? This marker has mass. I can put it on a balance and I can figure out what its mass is. I can tell you that this has maybe like 6 grams of mass here, right? But this marker also has a volume associated with it. I can calculate that. It's basically a cylinder. So I know the radius of the cylinder, I know how long the cylinder is, I know some math, so I can calculate the volume of this guy. So I know its mass, because I can measure that, and I know its volume, because I can measure that too. And what happens is if you take the mass and divide it by the volume, you get what we call density. It's mass per volume, or mass divided by volume, however you want to think about it. Basically, in layman's terms, density is trying to tell you how much mass something has compared to how big it is. Because when you think about it for a second, the mass of an object, the mass of a pile of lead here, yeah, it's important to know what that is maybe, but the mass of a pile of lead is not really a great property of the substance, because maybe my pile is this big, maybe my pile of lead is this big, maybe my pile of lead is as big as a house. So when I measure the mass of something, that's useful to know, but it's not the whole story if I'm talking about the property of the thing, because I may have a truckload of lead. Likewise, maybe I have 3 feathers in my hand and I can take the mass of those feathers, not going to be too much weight or too much mass. But what if I have, an entire backyard full of feathers, or maybe an entire basketball stadium full of feathers? It's going to have a lot of mass, but it takes up so much volume. So when you really want to compare two things, you can't just talk about the mass, usually. You need to talk about the mass in relation to how much space it takes up, which is the volume. So that's why we define something called mass per volume, and that's what we call density. So let's go and put some numbers to it to make sure you understand. So we're talking about the topic of density. All right. So what we know is that object has a mass in kilograms. You can measure it in grams, you can measure it in kilograms, you can measure it in other units, but these are all basic units of mass. And we also say that objects have a volume. Now this volume can be measured many ways. Maybe we measure it in cubic meters. Maybe we measure it in cubic centimeters, right? Maybe we measure it in cubic millimeters. These are all the same thing, they're just different units. Or maybe we might measure it in terms of liters. You might think of a 2 liter of soda. Well, that's 2 liters, that's a unit of volume. So we might measure it in liters. We might measure it in milliliters, which is 1/1000th of a liter. These are all different ways to describe the volume of something. Maybe you have a very large volume. It may make a whole lot more sense to use cubic meters because that's a large unit. Maybe you're talking about just a drop of liquid. It would be silly to talk about cubic meters of the drop of liquid because the unit's so big, but we might instead want to use milliliters or, cubic, actually this should be cubic millimeters here, cubic centimeters or something like that if we're talking about a small unit there. So these are all different ways to talk about the volume of something. Now when we combine these two guys, right? When we combine these two guys, the density is equal to the mass literally divided by the volume. So if you measure some mass, stick it in your calculator, measure a volume, stick it in your calculator, and divide those two numbers, you're going to get the density here. All right? Now, when we're talking about volume here, just to kind of give you an idea, when we talk about cubic meters or cubic centimeters or cubic millimeters, maybe I have a volume of an object here. I'm drawing it as a cube because it's easier for me. Maybe this guy is 1 meter on this side. Maybe it's 1 meter on this side and 1 meter deep. So how would I find the volume of this guy? The volume of a cube is the length times the width times the depth, or length times width times height. So 1 times 1 times 1. So this would be 1 cubic meter. So 1 cubic meter literally is a cube, 1 meter on every side. 1 cubic millimeter is a cube of 1 millimeter on every little side. So that's basically what these units mean. So when we take the mass in kilograms or grams or whatever, and we divide by the volume in any of these valid units of volume, then what we're going to end up with is what we're calling density. Now the units of density, usually we write the density as just a couple of examples. We might measure it in kilograms per cubic meter. Okay, we might measure it in grams per cubic centimeter. We might measure it in grams per milliliter. Now make sure you understand what this means. You need to get in the habit in chemistry. When you see a fraction bar like this with units, it means per. So this is kilograms per cubic meter. Think about what that means. Very, very important. Don't just gloss over things trying to get to the next topic in chemistry. That's a great way to not do well in your class. Make sure you understand everything. When we say something has so many kilograms per cubic meter, that means that if I take the substance and I take a cube of it, 1 cubic meter, which means 1 meter wide by 1 meter deep by 1 meter tall. Imagine a box in your living room, 1 cubic meter. And I fill it up with this object that I'm talking about here. Then the density of the object, if it's, let's say, 5 kilograms per cubic meter, that means if I fill a cubic meter of it, it's going to have 5 kilograms of mass because it's 5 kilograms per cubic meter. That means for every cubic meter that I take of the stuff, it's 5 more kilograms. 5 more kilograms, 5 more kilograms, every time I box up another cubic meter of it. If I'm talking about something smaller, it might make a whole lot more sense to talk about grams per cubic centimeter if it's a physically smaller object. So maybe this guy, what do you think? The volume of this, not really sure, I haven't calculated, but it might be 7 or 8 cubic centimeters. I think I could probably fit 7 or 8 cubic centimeters inside the volume of this marker. This marker might have a mass of 5 or 6 grams. So if it were 5 or 6 grams divided by 5 or 6, whatever it is, cubic centimeters, I would divide those two things and I would get a number. And that would be how many grams per cubic centimeter of this object. That's what it is. If you chop it up into that small little volume, that's how much mass will be in there. And that's why it's useful to compare two objects using the term or using the concept of density, because when you divide them like this, basically you kind of equalize the scale so that it really doesn't matter how much of it you have. You're comparing the same physical volume for the two objects. So when you compare the two guys, it makes a little bit more sense. And we'll do an example here to show you that right now. Let's say I have 1 cubic centimeter of, and also when you see something like centimeters cubed or meters cubed or something like that, when you see this, don't try to say it as centimeters cubed. That doesn't help you too much. Try to say it as cubic centimeter. Then you get in your head the idea that it's really a cube that has 1 centimeter length on each side. Okay, so let's go ahead and do that. Let's say that we have 1 cubic centimeter of each of the following things. Let's say I have cotton, which you know from experience is fluffy and white and really seems to be kind of like something that doesn't have a lot of mass to it. And let's say I have lead. which we know to be something kind of heavier, something that's going to, we use it when we want to weigh something down. Something that's really light, something that's really not so light. But let's say that in both cases I only have 1 cubic centimeter of each of these things. So picture a little cubic centimeter. So a little centimeter, a cube with 1 centimeter length on every side of it, right? And that's how much cotton I have, and that is also how much lead I have. So we say that the density is equal to the mass divided by the volume, for each case. But we know the volume is the same. We know we have 1 cubic centimeter of each thing. So let's say that for the cotton, let's say I know that I have 1 cubic centimeter, all right? But if I'm going to have the same amount of lead and cotton, I know I'm going to have less mass. I could put a number here, but the number really doesn't matter. I'm going to have less mass for that same volume. So over here, I'm going to have exactly the same volume. And so if I have the same volume, I'm going to have more mass. So make sure you understand what I'm doing here. What I'm saying is if I have 1 cubic centimeter, the same volume of cotton, and the same volume of lead, the volume is represented here in the bottom. There's a sort of an implied 1 out here in front because it's 1 cubic centimeter in each case. So if I have 1 cubic centimeter in both cases, then I'm going to have less mass. That's what the M is, less mass when I'm talking about the cotton. I'm going to have, relatively speaking, more mass of the lead. So when you think about it for a second, if you have a lower number here and a higher number here, then what we're saying here is the density of the cotton, right, is less than the density of the lead. Density of the cotton is less than the density of lead, because if you think about it, this might be, let's say 2 grams per cubic centimeter, right? But for the same volume, this might be 50 grams per cubic centimeter, because it's going to weigh more. It's going to have more mass for the same exact volume. So when I do the division, I'm going to get this density. It's going to be grams per cubic centimeter. And that number for cotton is going to be less because it's got less mass for the same volume. That number for lead is going to be higher because I've got more mass for the same volume. So the density of cotton is going to be less than the density of lead. And that's what you might see in a book. You might see a table of densities in a big fat book that represents all the substances or something. You might look at it and you might see the density of cotton is 3 grams per cubic centimeter. You might see the density of, gold at 100 grams per cubic centimeter. I'm making this up, but the heavier objects that we sort of see in everyday life compared to their volume, they're going to have higher densities than the fluffy items like that. Okay, one more thing I'll say, and this is sort of just a tidbit sort of thing that you should keep in mind as we move on. These are all valid ways to describe volume: cubic meter, cubic centimeter, cubic millimeter. We also talk about liters, because you think about your 2-liter bottles of liquid, and milliliters, right? Which is 1/1000th of that. One thing for you to know, just sort of a mathematical equivalence, 1 milliliter happens to be exactly equal to 1 cubic centimeter. So if you see something in grams per cubic centimeter and grams per milliliter, because these volumes are exactly the same, it's just something I want you to remember, because you might see cubic centimeters written somewhere, and you might see milliliters written somewhere. The way the units work out, those are the same thing. 1 cubic centimeter is equal to 1 milliliter. That's something you might want to file away in your head, because as we work with volumes of chemical substances later on, that's going to be really helpful for you. So that is the concept of density. There's really nothing more to it than that. You take the mass of something that you have in the lab that you measure its volume, you divide the two numbers, and you get a number that represents sort of a physical property of that substance. Mass per unit volume, mass per cubic centimeter, mass per milliliter, or something like that. And it's very, very important to characterize. So what we're going to do now is work a few problems to give you a little bit of practice with density, because it's really not that hard. First problem says a 25 milliliter sample of liquid bromine has a mass of 78 grams. What is the density of bromine? So what we need to do is realize that the density is equal to mass divided by volume. This is one of those equations that you just memorize, but hopefully after talking about it, you'll understand why it's equal to mass divided by volume. So in the problem, we know what the mass of this sample of bromine is, it's equal to 78 grams. So 78 grams, and we're dividing it by the volume. The volume was also given to us by 25 milliliters. Remember, this is a unit of volume. It's 1/1000th of a liter. It's also equal, 1 milliliter is also equal to 1 cubic centimeter. But it just the way it happens to be written in the book could be written either way. So what we need to do is take our calculator, 78 divided by 25. When you do that, you're going to get 3.12. That's the number, but don't ever write just a number down for the answer to a problem. You need to have a unit. What are the units here? Grams per milliliter. Grams per milliliter. So what does this mean? That means we've calculated the density of this sample of bromine that we have. We measured its mass, we measured its volume, we divide the two numbers, and we know now that the density of any sample of bromine is 3.12 grams per milliliter, or the same thing per cubic centimeter. So what it means is if I take a drop of bromine, measure out exactly 1 milliliter, then the mass of it should always be 3.12 grams. So if you're comparing two liquids or two chemicals or something, then knowing their densities can help. That's basically a physical property of that substance. It's intrinsic to that substance, because every time I measure out another milliliter of bromine, I'm going to get another 3.12 grams. That's what's going to be the mass of it is. Okay, so let's go on to a different type of problem. Similar kind of concept, but it goes like this. Metal chips have a volume of 3.29 cubic centimeters, and they're placed on a piece of paper and they're weighed. The combined mass of these two guys, when we take the mass of them, is 18.432 grams. If the paper has a mass of 1.214 grams, what is the density of the metal chips? What is the density of the metal chips? So what we want to know is calculate the density of that metal. So what we need to do is write down what we know. The density of the metal is going to be the mass of that metal divided by the volume that that metal occupies. But the problem doesn't really give us that information exactly, because we know the volume of the metal chips, we actually know, 3.29, so we know that. But we don't know the mass because we put it on a piece of paper, and we know that the combined mass of the paper plus the metal, so we have to do a little bit of work. What I suggest, if you're not sure what to do, is always draw a picture. A picture is so incredibly important in chemistry and physics and almost all branch of math and science. If you can draw a picture to help you, then please do it. So here's a piece of paper, and here's some metal chips on top of the paper. Believe me, I'm not an artist. It doesn't have to be perfect. But what you do need to tell yourself is that the mass of these two things combined together is given to us in the problem, 18.432, and that's grams. And I'll put the grams in brackets just so you don't get confused. It's not a 9 or anything. It's 18.432 grams. That's the combined mass of all of it. So I drew a little bracket to show myself that. Now, in addition to this, we also know that the paper by itself weighs has a mass of 1.214 grams. So if we know the mass of the paper and we know the mass of the combined thing, then all we need to do is subtract these two numbers to figure out what the mass of the actual metal, what the mass of the actual metal is sitting on top, which is the number we need to stick in here, because we're not interested in the mass of the paper. We're trying to calculate the density of the metal chips. So we need the mass of the metal chips. We need the volume of the metal chips. Okay, so let's go ahead and do that. Let's say that we have the mass of the metal is equal to the combined mass of the paper and the metal, so 18.432 minus 1.214. Okay, so the mass is equal to, when you take 18.432 and subtract 1.214, you'll get 17.218. And the unit is grams because we're subtracting grams minus grams, so the unit is grams. 17.218. And that's the mass of the metal chips that's sitting on top of the paper. So now we have everything we need. The density is equal to the mass divided by the volume. The mass we just calculated is 17.218, and that's grams. And the volume, right? The volume is the volume of the metal chip, and that was also given to us in the problem, 3.29 cubic centimeters, 3.29, and the unit is cubic centimeter. So now all we have to do is divide these two numbers. The density is equal to 17.218 divided by 3.29. We'll get 5.23, and the unit is grams per cubic centimeter. Grams per cubic centimeter. And I just like to usually keep things in brackets. It helps me not confuse the unit with the numbers. So that's what that means. This particular sample of metal, whatever it is, could be aluminum, could be gold, could be silver, whatever it is, every time I take a cubic centimeter of that material, I should have a mass of 5.23 grams. If I have a truck full of the stuff and I shovel out 1 cubic centimeter, I should have a mass of 5.23 grams. Every time I do that, every time I take another cubic centimeter out, I should have the same mass, because the density is something that is a intrinsic property of the substance that applies to every part of the substance, no matter, you know, if it's on this side of the truck or that side of the truck. It's a property of the metal. So every time I get the same amount of volume back, I should have that amount of mass. That's what the volume, that's what the density means. Okay, the next problem is a rectangular block of lead is 1.2 centimeters by 2.41 centimeters by 1.8 centimeters on each of its sides. If the block's mass is 59.01 grams, what is its density? Same exact concept. We know that the density of any substance is equal to that substance mass divided by its volume. So all we need to know is the mass and the volume. Now we know the mass, that's given to us by 59.01 grams. But the problem doesn't really give us the volume. So you have to find that some kind of way. You have to look in the problem and see what can you use to calculate the volume. It so happens that you know the dimensions of this cube. So we're able to calculate the volume. If you think about it, the block, I should say, is, you know, I'm not drawing it to scale or anything like that, but it's a block. It says it's a block, a rectangular block. So what we know is on one side it's 2.41 centimeters. On another side it's 1.20 centimeters. And the only other side left would be this one. So this guy is, let's say, 2.41. Actually, we've already used that guy. The other guy is 1.80 centimeters. So we know the dimensions in length, width, and height. So how do you think we calculate the volume? We're just going to multiply them. That's how we calculate the volume. So the volume is going to be equal to 1.80 times 2.41 times 1.20, 1.20. So the volume, when you take these guys and multiply it, 1.8 times 2.41 times 1.2, you're going to get 5.21. But don't just leave it like that. You have to have a unit here somewhere. What should your units be? What you're doing is you're multiplying centimeters from, you know, everything is centimeters. Centimeters times centimeters times centimeters. So you're going to get centimeters cubed, because you have centimeters times centimeters times centimeters. So centimeters cubed, or cubic centimeters in other words. So the volume of this block is 5.21 cubic centimeters. If you can imagine what a cubic centimeter looks like, being 1 centimeter on each side, take 5.21 of those, that's the volume that we're talking about in this problem. So that volume is going to go straight into here. And the mass was already given to us. So the density is going to equal, the mass is given to us by 59.01, and that was a unit of grams. The volume is what we just calculated, 5.21, and the unit here is cubic centimeters. So all we need to do now is divide these two numbers. 59.01 divided by 5.21 is equal to 11.3, and the unit is going to be what? Grams per cubic centimeter, because grams per cubic centimeter. So we divide the numbers, the unit stays here. So again, this means that if I take a cubic centimeter of this material and put it on top of a balance to measure its mass, I'm going to get 11.3 grams, because I have 11.3 grams for every cubic centimeter of that material. So I've tried to emphasize that very, very clearly, because a lot of students get confused with density. It's something that, you know, you have experience with it in your everyday life, but never to sort of like the mathematical definition like we have here. So I hope that I was able to break it down a little bit, give you a good solid foundation to what density is, because as we go forward talking about different substances and properties and materials, it's really a shame if you don't get chemistry because you don't understand the terminology. It's very important to understand the terminology. And here we've practiced a few problems to teach you what density is, how you might interact with it in your daily life, why it's important, and most of all, how to calculate the proper density when you're given different sets of information. So these kinds of things will definitely help you on your exams and on your homework. Learn anything at mathandscience.com.